For comparison, here's a speedrun of how coroutines work in Unity. First, we have to make sure our script has using.system.collections at the top. Then, we write private or public, specify an IE numerator, name it, I've called it my coroutine, add parentheses, brackets, and then somewhere we have to write a yield return statement based on what we want to wait for. Now we just start the coroutine somewhere and we're up and running. In Godot 3.5's GDScript, coroutines used the yield keyword, similar to C#. As of Godot 4, this is no longer the case. The yield keyword has been replaced with the await keyword, and the core functionality of coroutines has changed slightly. As outlined in the Godot 4 documentation, unlike yield in previous Godot versions, you cannot obtain the function state object. This means we can no longer directly modify a coroutine at runtime like you could in Godot 3.5. In Godot 4, once a coroutine has begun running, we cannot modify, pause, or resume it. We can only start it and stop it. This gives us type safety, similar to C#, to ensure we don't write ourselves into a debugging nightmare down the road. Okay, with all that covered, here's how we accomplish a coroutine in Godot 4. I have created a blank project and used a node 3D as my first node of this scene. On this node, I attached my script. In this small example script, I have a variable and a signal declared at the top. I've explicitly declared testBool's type as a Boolean, and I've called my signal boolSignal. In the enterTree function, which is similar to awake in Unity, I set testBool to false. In the ready function, which is similar to start in Unity, I run timer. Let's take a look at the timer function. First, we enter the function and print this line. Next, we use the await keyword to create a timer, which will wait 3 seconds and then send the timeout signal. If you don't add this signal, the function won't be recognized as a coroutine and await will not work. This is because await is specifically designed to wait for signals. Next, we print that 3 seconds have passed and set our testBool to true. Finally, we print the state of our testBool. Let's run the active scene with F6 and watch the output window. As you can see, we have successfully implemented a basic timer in this function, making it an asynchronous coroutine that will not prevent other code from running. I'm going to stop my project from running with F8. We can see that our coroutine is asynchronous if I uncomment the print test function I've written. This simple function will print test immediately after our coroutine function runs. Immediately after our coroutine begins waiting, GDScript continues on, while our coroutine awaits for 3 seconds before running the rest of its code. In the C# code from earlier, I had a coroutine which waited until testBool was true. Here is one way you can achieve similar functionality in a GDScript coroutine using signals. First, I'll uncomment this line, which runs my wait until bool true coroutine. Once entered, this coroutine will await indefinitely until the bool signal has run. Finally, I'll uncomment this code that fires the bool signal. This will let the coroutine know it's okay to continue its execution. Let's take a look at the output. As you can see, once the coroutine finished running, it emitted the bool signal, which allowed our wait until bool true coroutine to continue. I have linked the relevant Godot 4 documentation below. I highly recommend you read it yourself to get an even better understanding of how coroutines work in Godot. I hope this short tutorial helped you. If you have any questions or feedback, please leave them in the comments section below. If you'd like to follow me for updates on my game projects, I've linked my social media pages below. Thank you for watching and have a great rest of your day.